What's up guys, welcome to Code Obsessed, and today we'll start the new Leetcode daily question 714. Best time to buy and sell stock with a transaction fee. Okay, so before we start this question, I'll take you through another question which is basically the base concept of this question. If we can do that question, this is basically a piece of cake. Okay, so we'll head over to that question and I'll just open my OneNote and we have best time to buy and sell stocks too. Okay, so this is a very standard DP question. Now let's start with the intuition. Okay, like how will you actually understand that this is the DP question, right? Let's start with the intuition. We'll just read the problem statement is that you are given an integer array prices where prices of I is the price of a given stock on the ith day. Basically both the questions are very similar. Just go through with this. Okay, one day you may decide to buy or sell a stock. You can hold at most, this is a very important point, you can hold at most one stock at any time. However, you can buy it then immediately sell it on the same day, and we have to return the maximum profit. Okay, so what the question is saying that we are given an array prices, right? On a given day we can either buy a stock or sell a stock. Obviously you can only sell a stock after you have bought it, obviously, isn't it? If you don't have anything you can't sell anything, right? So you have to first buy a stock and then you can sell a stock, right? And if you have bought a stock you cannot buy another stock, you have to first sell the before off. Okay, you have to sell the first stock off before buying the next one. This much part is clear because these both of these things are very important and because that's the kind of the base of the question. Okay, so what's the intuition? Now we know on a given day we can either buy or sell. These can also be subdivided into, the buy part can be divided into, on the given day we can either choose to buy or just skip the day, just choose to not buy. Okay, so not buy and buy. For the sell thing also can be used to same thing. Okay, if we have bought a stock we can either choose to sell it or not sell it. Simple, right? It's our choice. Maybe we have a stock, maybe, okay, let's just take an example. Maybe we bought a stock on day 1, it was 7, next day it's 1. Would you want to sell a stock that you have bought for 7 units and you want to sell it off for 1 unit? I don't think so, right? So you'll wait if you want to sell it for maximum profit. Similarly, maybe you don't want to buy the price at the stock at 7. You might think, oh, maybe the stock will go down the next day, so you just don't buy it that day. See, and it does. It goes down to 1. So there's all these options. Okay, there's not a single way there. You can't just go with greedy. When all you have to try out all things, the best way to do it is recursion. Recursion. Okay, and we'll start with the recursion code, but just a reminder, like if you try the recursion code it's going to give you a TLE. It's completely correct, but it's just going to give you a time limit exceeded because there are overlapping sub problems, and we'll see everything as we go to the dry running of the case. Okay, so we have the prices array which is 7, 1, 5, 3, 6 and 4, right? So as I mentioned above, on a single given day we have a choice. Okay, we have a choice to either buy a stock or not buy a stock, sell a stock or not sell a stock. Okay, let's start with the 0th index. Okay, let's start on the 0th index. We'll start on the 0th index. I'll just mark the index 1, 0, 1, 2, 3, 4, 5. Yep. So we'll start right here. And okay, we'll keep track of our index as we go, and we'll keep track of one more thing is can we buy a stock or not? If you remember correctly, we can only buy one stock at a time. If we have bought a stock we cannot buy another one, so we have to sell it off before buying another one. So we'll keep track of if we can buy a stock. Okay, simple. Yeah, so let's start off with 0th index, and in the start we can buy a stock. Obviously we don't have any stock with us, we're just starting off, so we don't have a stock. So now when the option is 1, that we have an option to buy, we have two options. We can either buy a stock or not buy a stock. And this recursion, the output of this recursion is gonna give me the profit, maximum profit I can make. This every single step of the recursion give is gonna give me the output of maximum profit that I'll make at that given day, right? So if I were to buy a stock, okay, what will be the profit I make? It's gonna be -7, which I spent in buying the stock, plus something that is gonna be given to me by the maximum profit of the next recursion, right? You guys know how recursion work, right? Okay, maybe this will be a little confusing for you guys, so we'll go through like bottom, we'll just come up slowly, right? Okay, So let's say we bought a stock, right? So it's obviously we took -7 to buy a stock. Okay, that makes sense. You lost 7 units of your whatever money you had into buying a stock. So now you are at first index, and since you just bought a stock, you cannot buy another stock. And if you choose not to buy a stock, we'll be at zero money. We didn't spend anything, we didn't sell anything, we're at zero money, no loss, no gain, and we'll be at the next index and we can still buy a stock. Make sense? Obviously, we can still buy, right? Because we didn't buy the last time. I'll just write the array below as well. For convenience, it was 7 1 5 3 6 4. Okay. Right. So we can still buy a stock here. 1 means we can buy a stock, 0 means we cannot buy a stock. Okay. Okay. Now 0 comes up. We cannot buy a stock. So what's our options? We can either choose to sell a stock or we can choose to not sell a stock. Simple. Since we can't buy it, our only option is either we'll go to the next index, we won't sell it. We'll just, yeah, I'll just keep it. I don't want to sell it right now, or we'll sell it off. Right. Now we are at this index. What if we choose to sell it? What will be our profit? Our profit will be 1. That will be a profit plus 1 because we sold it. That's not a profit. I mean, that's the amount of money that's gonna be. Let's just say we have a bank account, right? So how much money at the end of the day we'll earn in the bank account is gonna be decided by the recursion, right? So at this step we got a plus 1, but at this step we took a -7. Net, we ain't making profit right now. But let's move on, right? We go to a 2 and now we can buy. Right, since we sold the last stock, we can buy a new stock. Simple enough. And if we choose not to sell it, we have a 0 gain because we didn't sell it. And we go to the next index and now we still cannot buy because we haven't sold the stock. We still have the old stock with us. Right, and this continues on. We go down, we have 1. That means we can buy. So it's going to be a buy or not buy. We cannot buy here, it's a 0. So it's going to be a sell or not sell. Right. Um, for your understanding, let's take a very small example so we can, get the grasp of the whole recursion tree, because I don't think we have the time to make the whole recursion tree for the above example, right? We'll take a small example. Let's start off with 1, shall we? Let's start off with 1. The 0, 1, 2. Our first recursion is index 0. We can buy. We get 2 options, buy or not buy, B and NB. So if you buy a stock, we have a plus 1, a minus 1. We bought it for 1. So we have a -1. And we go to the next index. We have a 1 and a 0. Simple. 1, 4, 9. Okay. 1, 4, and 9. Right. So now we are at 0. So obviously we cannot buy the stock. So only option is sell or not sell. And we are at 4, the element number 4, which is the first index, right? The first index. Okay. So now we are 4. Now I'm thinking, okay, I have 2 options. We can sell or not sell. If we were to sell, we'll make a plus 4. And if we were to not sell, we'll make a 0. And we'll go to the second index, but we still can't buy because we didn't sell the last one. But this time around, we can buy as we sold the last one. So we'll go to 2, 1. Now again, I get 2 options, the buy, not buy. If we were to buy, I get a -9. Took 9 cost to buy the stock. And if we don't buy, I get a 0. I didn't buy anything. I didn't spend anything. I didn't gain anything. So it's a 0. Here we have 2 options, to sell or not sell. If we sell the stock, we get a +9. If we don't sell the stock, we get a 0. Right. Now you want to make the maximum profit, right? You want to make maximum profit, right? So you want to get the max of both left and right. This is the amount of money that is transferred. Basically, the plus and minus simply signifies if you gained the money or if you lost the money. Okay. So you spent money to buy a stock, -9, and you gained to spend nothing over here. Okay. Since this is the last transaction, we'll just take the maximum of them. So maximum comes out to be a 0. Okay. So the amount of money now here, the amount of money you gained or spent will be the money plus 4 here plus the amount returned by this, which is 0. We go back. Now for the right subtree, we return 9, and this is gonna return 0 plus 9 now, which was returned from here, so 0 plus 9. And now since this returned 4, this returned 9, we'll take the plus 9 as the maximum, and we spent 1 to buy the stock, so it's minus 1 plus 9, which comes out to be 8. So this was the answer of the left subtree. Let's say it again. I'll just do a quick revision of the whole thing. Okay, just do a quick revision. The buy, not buy, simply we buy, we get a minus 1, and what we are left with, index 1, and we cannot buy anymore, right? And if we not buy, we go to index 1 and 1, and we are left with a 0 over here. I'll just write up top so it's less confusing for you guys. Okay, so this line is minus 1, this is giving a 0. Now we get two options once again: sell, not sell. If we choose to sell, we get a plus 4, and if we choose not to sell, we just get a 0, right? So if we sold, we'll come down to another option to buy, to 1, and if we were to buy, we get a minus 9, and if we didn't buy, we get a 0. So we'll take the maximum of these two and return, we return 0. We add it in this. Similarly, here we get 2 comma, it's a not sell, so that's a 0, and now we sell or not sell, not sell 0, sell gives us a 9. We choose the maximum out of this, which is a 9. So we have a 0 plus 9, and we return this. 0 plus 4, we return this. We get 4 from here, 9 from here. We take the maximum. 9 is returned here, so minus 1 plus 9 is for the left subtree, this side. Now we have to do the same for the right subtree, but that is the homework. Okay, the right subtree is going to be your homework. I'll just show you what the recursion tree is going to be like. We have not buy, so it's going to be a 1 1. We have another chance to buy, so either buy or not buy. If we were to buy, we'll get a 2 0, and if we get not buy, so it's a 2 1, right? So you can just take the amounts that gonna plus and minus, and we'll just head up straight to the code. Okay, so let's start with the coding part, shall we? So we'll just start, we'll take a vector and an integer n, which is the size of prices. So prices dot size, right? And we'll just take, I guess, solve. Yeah, just make a function int solve, and it will have the starting index, the int I. It will have int buy, which will tell us if we can buy a stock or not. It will have the prices, the vector, which I'll just copy, and the pieces as well, so I'll just copy both of them. Okay, and this is going to be our function. So we'll return solve of, let's start with 0th index. We'll keep buy at 1 in the starting, since we can buy a stock in the start, and we'll have the prices, we'll have the fee, right? So let's think of the base case, shall we? The base case is, okay, you just look at the things that are changing. Okay, what can be the base case? The two things that are changing are buy and int I. Okay, the buy only takes two states, 0 or 1. There is no base case, it cannot go other than that. So I, on the other hand, is constantly increasing. We get the first index, the second and the third index, so it has a reach, like it has a limit, it has an upper bound. So what is its upper bound? If I becomes equal to prices dot size is its upper bound. What do you mean price dot size? Okay, so if you remember, the indexing starts from 0, right? So it's 0, 1, 2, 3, 4, and 5. Like, and the size of the array is 6. So as soon as the I reaches 6, it is technically beyond the scope of the array, and there are no stocks after the price of the array. So if there are no stocks, you can't make any profit or any, like, you can't. There is no transaction, basically no profit or loss. So you just return 0. Just return 0. Simple as that. Okay. So now we know buy can take two options. It's either gonna be buy, oh boy, buy equal to 1. Okay, so either we have an option to buy, and if we can buy at that day, we can have two options. Either we'll buy the stock or we'll not buy the stock. Okay, so let's take int buy. Int buy means you can buy the stock. So if you buy the stock, you spend prices of I amount of money, plus we'll call the recursive solution for I plus 1. And now this time around, since we bought a stock, okay, we can't name it buy obviously because the name of the uh, yep, we can't use the same name, simple as that. So let's take okay, I'm gonna just take, who cares. So now since we just bought the stock, we cannot buy it again, so we'll put buy equal to 0, and then we have prices, then we have the fee. And the only difference between these two questions, by the way, the buy sell stock and the one I taught you, is the difference in the fee. Okay, so that did not have the fee, and the only change we make is that this time around there is a transaction fee. So every single time you complete a transaction, that means you buy a stock and then you sell a stock, you have to pay a fee. Okay, so I'll just tell you how that's gonna get included over here. Till then, we'll just write in the code of the normal buy sell stock that we have done till now. So if we are not buy, let's say int not take is equals to, we make 0 profit, and we get solve of I plus 1. Since we didn't buy, we can buy it again. Prices comma fee. Okay, and since we have to give the maximum profit, we're gonna return the max of take comma and not take. Similarly, if this time around we cannot buy it, buy is equal to 0. This time we have two options. We can either sell the stock or not sell the stock. We sell. If we sell the stock, we get plus prices of I, but the only difference, as I was saying, is that we have to incur a transaction fee. So we'll subtract the fee from the total gain. Okay, so we get the prices of I for which we sell the stock, and then we reduce the amount of fee, transaction fee, that we have to spend, right? And if we were to not sell it, not sell, simply no gain or loss, so 0 plus, okay, so if we sold it the last time, this time we can buy. Okay, so since we sold it, we can buy it on the next indice. And if we decide to not sell it, that means we cannot buy it. We still have a stock with us, so we cannot buy a new one. And once again, since we have to get the maximum profit, we take the not sell and sell and return its maximum. So that should hopefully give us the right answer. See, yep, accepted. Now I'm pretty sure it's going to give me a TLE. The recursion solution gives a TLE, so we'll need to optimize it. So for that, we'll use a DP. See, we got a TLE, right? So we'll use a DP. So how do we define a DP array? Okay, so we see the amount of things in our function that are changing, amount of parameters that are changing. This time we have two parameters, I and by, that change. I can take a value from 0 to n minus 1, and by can take a value from simply uh, 0, 0, 1. Okay, so we'll define a vector 2D vector, since there are two changing parameters. DP size n plus 1 comma vector int 3 comma minus 1. And yeah, we'll have to add dp in the function parameter as well. So we'll just copy this, we'll add dp here, we'll send it to the function, we'll pass it by reference, and then simply if dp of I and by is not equal to minus 1, we return dp of I and by. And every single time when we are returning an answer, we'll just write dp of I and by is equal to and return the answer. Similarly here, that should do it, and we have to get a dp on all of these. So a dp, and let's hope that works. Yep, accepted. And as soon as we hit the submit button, that should, yep, that got accepted. So yep, that is our memoization solution. Memoization. Let's head towards the tabulation solution. Okay, towards the tabulation part. Now, the only difficult part of the whole question is the recursion, basically. After that, it's pretty much just the same things that you do in every DP question. Okay, so we'll just copy this much part of it and we'll just comment the whole thing because we don't need that. And we'll go to the tabulation part, simple as that. for tabulation, we'll just define the vector. And okay, now how do you do tabulation? Now we'll define a vector once again, the amount of changing parameters, the degree of the vector, and then we'll take the same amount of for loops. Okay, and tabulation is completely opposite of memoization. So in memoization we started with, if you remember, we started with I equal to 0, and it went on till n minus 1. For this case, we'll start from I equal to n minus 1, I greater than 0, greater than equal to 0, I minus minus, by, once again, it's only two states, and by equal to 0, by less than equal to 1, by plus plus. So that's our two loops, simple as that. And now we see what the base cases were. So base cases was a very simple base case, that if I equal to price dot size return 0. So we'll just initialize the dp vector as 0, that way we don't even have to write the base case, and there are no other base cases. Simple. So now we have written the loops. Now to convert memoization to tabulation, we just look at our recursion, and we simply just copy paste it. Like, we don't even think about, we just copy paste the whole thing. Just copy paste it, remove the comments, simple as that. Yep, and we copy pasted if by equal to 1, this part of the recursion will, and now we change the recursive calls. Okay, so it's solve of I plus 1 comma 0. This simply gets changed to dp of I plus 1 and 0. You see what I did there? Solve of, so now you tell, like, solve of I plus 1 comma 1, what does this change to? Yep, simply dp of I plus 1 and 1. And this time we don't have to return anything. So that's that. Once again, move the return part. Solve of I plus 1 comma 1 becomes dp of I plus 1 and 1. Solve of I plus 1 comma 0 becomes dp of I plus 1 and 0. And now at the end of the day, we'll return what we sent to the function call in memoization. If you remember, we sent um, ith index 0 and 1 to the function call the first time, that is we can buy, and we starting from 0 index. So we'll just return the same thing, return dp of 0th index and 1. And that should once again hopefully work. We got a small error. What did we miss? Oh, okay, we didn't write int. Okay, cool. We didn't declare I. Nice. So that should do it. I don't think I'm seeing any other. Yep, there you go. Both the cases accepted, and now we'll just submit. And voila! And that is our tabulation. Okay, so these are the basic memoization and tabulation solutions. If you guys have any doubts, just put them down in the comment section down below. I'll just try to since I can't really make the videos that long, I could potentially explain the whole DP thing in a lot of detail, but that would probably take a lot of time, and we can't really do that here. So yeah, if you guys have any doubts, just put it down in the comment section down below. I'll try to explain it to you guys. I'll just maybe uh, get into some social media or something. I'll just try to DM you some of those notes that I'll just specially make for you, so you can understand or something. So yeah, if you guys need any help, just put them down in the comment section down below. I'll be happy to help you out. Anyways, guys, if you like, please, if you have been here till the end, yeah, please make sure to like and subscribe, and just try to give that like, so it'll just keep motivating me. Thank you so much.